Hi, this is Mr. Roix. Sorry about getting this up late. I was having problems getting it connected to the internet. But let me take you through question number 5. And so 5 is asking us if there is a certain amount of bromine in the seawater and we are extracting bromine from the seawater, and there's a limited amount of seawater. How long will it take for all of the bromine to be extracted from the seawater? And so what we're going to do is we're going to start this question with the total mass of seawater, which is 1.3 times 10 to the 21st kilograms. It's a large number. And then what we're going to do is we're going to convert the kilograms of seawater to kilograms of bromine. And so we know that seawater is 0.006% by mass. So we could say if I have 1 kilogram of seawater, we're going to take our percentage and make that a decimal, which means moving the decimal point 2 spots to the left, so it's 0.0006 kilograms of bromine per kilogram of seawater. Now, the other way we could write this is we could write this as 6 times 10 to the negative 5th. That's another way we can do that, and that might be more useful to do it that way since we're already dealing with exponents over here. All right, so now that we have it in kilograms of bromine, you'll look and the amount of bromine that's extracted is in tons, so we need to go from kilograms to pounds. So again, there's a number of different factors we can use. We're going to use that 1 kilogram is 2.2 pounds. Now we want to get to, now that we have it to pounds, we want to get to tons. So we could say there are 2,000 pounds per 1 ton. And the last thing is, since it's asking how long, it wants to know a time unit. And what we have for our time unit is we are told that each year 1 times 10 to the 5th tons of bromine is extracted. So we're going to bring that 1 times 10 to the 5th tons is equivalent to 1 year of time. And now, since we have it in years, let's double check that all our units will cancel. So we have kilograms of seawater, cancel kilograms of seawater. We have kilograms of bromine, canceling kilograms of bromine. We have pounds of bromine, canceling pounds of bromine. We have tons of bromine, canceling tons of bromine. And if we did this all properly, we should get an answer in years. And now we do the math. So just very quickly, we're going to do this as an estimation, and then we will do the actual figure. So I'm going to make this into scientific notation. I'm going to call that 2 times 10 to the 3rd. And so again, with scientific notation, remember when you are multiplying, you add exponents. When you are dividing, you subtract exponents. So let's quickly do this in estimation, then I'll give you the actual figure. So if we look at the first value, 13 times 10 to the 21st, if we multiply that by 6 times 10 to the 5th, or not 13, but 1.3. 1.3 times 6 is going to give us 7.8. And then we add the exponents. We got 21 and a negative 5, so that's going to be 7.8 times 10 to the to the positive 16th. 7.8 times 10 to the positive 16th. If we multiply that by 2.2, 7.8 times 2.2 comes out to be 1.71 times 10 to the 17th, times 10 to the 17th. And then if I divide that, half of 1.7 is going to be 8.5. So 8.5, and we're subtracting the exponent, so we were at 17, so that's 14. And then over here, we're then going to subtract another one, so now we're down to, 0.85 to the 9th, which in scientific notation would be 8.5 to the 8th. So that's my estimation, 8.5 times 10 to the 8th power. And when I do it in the calculator, the answer I come to is 8.58 times 10 to the 8th power. So pretty close on the estimations. We'll practice with working through scientific notation, and so you guys should be able to kind of come up with some of these estimates without using a calculator, so you know you're in the right ballpark. But 8.58 times 10 to the 8th years, that's again 858 million years before we extract all the bromine from the sea. So we got some time. All right, we'll see you in class.